G'day. This is a water usage video, and the particular aspect of water usage we're having a look at today is rainfall. Statistics are used to analyze rainfall figures, and we can be asked to use statistics to interpret measures such as the mean, the median, the mode, the range, and the interquartile range. Now we won't go into each of those and the ways to calculate those because there are separate videos on that in the statistical section of the website, so have a look at those individual ones if you've forgotten how to do the calculations. But we'll remind ourselves that the mean, median and mode are all statistics. They're called measures of location. And they're measures of the center of a bunch of scores, and in this case rainfall figures, and we look for the measures of center so that we can find some sort of a typical score. I mean, a batting average or a batting mean of say 40 runs per innings gives us an idea of what's typical for that batsman, and so a monthly rainfall figure, an average rainfall figure for say July, gives us an idea of a typical amount of rain that is falling in July. And also the mode might talk about the most popular score. That's the definition of a mode, or the score that occurs the most. So that can give us an idea of rainfall figures as well. Now we have range and interquartile range, and those two statistical measures tell us more about the spread. They're measures of spread. So we can use these statistical measures to analyze rainfall figures. Now one aspect that comes up is the effect of one very large or very small score for that matter on some of the statistical measures. So the mean and the median, they're both supposed to be measuring the location, or they're measuring a typical score in the center of a bunch of scores, but they can sometimes be quite different from one another if there's one really large or one really small score. Let's have a look at a quick look at an example here. We've got a bunch of scores, 2, 3, 4, 5, 6 and 7, all around single digits. And then we've got one really large score of 48. We'll just have a quick check as to see how that large score of 48 affects the mean or the median or both. Let's have a look. So the median of that set of scores, they're all in order there. You can see that the middle score, there's 7 scores altogether. The median will be 5. That's the middle score when they're placed in order. Okay, the median's 5, but when we add up all the scores and find the mean, by adding up all the scores and dividing by how many scores there are, we've got a total number of scores of 75. If we added them all up, and 48 helps a lot in that total, and we'll divide by how many scores there are, 7, and we get a mean that's much larger than we got for the median. 10.71 is the mean of that calculation to round it to 2 decimal places, and you can see that the median is 5, but the mean is 10.71. Now the median of 5 is a pretty typical score if you discount that 48, but the mean of 10 is much bigger, or quite a bit bigger, than 6 out of the 7 scores. So if you find with some of the statistical measures you use for analyzing rainfall, if you find there's a big gap between the median and the mean, it can be explained by the fact that there might be one really large or really small score in the data. So the difference comes about because the mean, when we calculate the mean, we add up every score and then divide by how many there are. With the median, we don't really get affected much by that really large score at all. We still can decide what the middle score is pretty easily there and not really be affected by the big score. So mean gets affected and median doesn't by one really large or one really small score. Now there's questions when we analyse rainfall about the probability of particular outcomes, particularly at particular amounts of rain. So let's sort of have a bit of a quick look at that. The probability of any particular outcome is calculated by finding the number of times that that outcome occurs and dividing by the total number of outcomes. So it's the number of items we're looking for in particular divided by the total number of outcomes that might occur. So the probability of an outcome equals the number of that particular outcome we're looking for over the total number, and that'll be a fraction. So let's have a look at a quick example here. We've got a table of rainfall figures all in millimetres here from January through to December, 12 months in the year, and the question says, based on the rainfall data in the above table, find the probability of rainfall being above 50 millimetres in any given month of the year. So we'll use that arrangement in the red box at the top there and look for the probability of an outcome. We'll find the number of that item we're looking for and put it over the total number of outcomes. So the probability in this case, let's adapt the rule in the box just to this particular question. The probability of rainfall being above 50 millimeters, which was asked for in the question, we'll look for the total number of months that are above 50 millimeters, and we'll put that over the total number of months that we're looking at. Now if we have a look at our table down here, I'll just circle the number of months if their rainfall is above 50 millimeters. No. May has a rainfall of 66 millimeters, that's above 50. June has a rainfall of 74 millimeters, that's above 50. We go across to September for the next one, that's above 50. October's well above 50, and November's above 50. So we have 5 months out of the year that has rainfall figures above 50 millimeters. So we have 5 items that we're looking for out of a total of 12 months. So the probability of rainfall above 50 millimeters, 5 months was the number of months that we were looking for, over the total number of months, which is 12. So the probability of rainfall being above 50 millimeters is 5 over 12 in this case. So that's just an illustration of how we can sometimes be asked about the probability of a particular type of outcome, and we can work out that probability based on our example there. So I hope that helps. That's all about rainfall and how we analyse it quickly. Just a few tips there to follow. Thanks for listening. peterblakemaths.com. All the best with your studies.